Hello, thank you, my friends that come in for support, and thank you, my students that have come in to support this channel. This is the first of the series. This is the first of the series that we call it Slow Catch the Monkey for your tuition. And I would love to inform all of you guys, okay, this session is going to be happening every Friday, same time, unless you do not see an announcement for the live stream, okay? And so this live stream is also, oh, thank you, my friend Brandon, for telling me all the informations that I need to know, yeah? Okay, so this session, what I will do is I will get all the informations for you guys, okay? And then what I'll do is I'll compile them and put in my live stream announcement, okay? So once you get the live stream announcement over there, hello Arisa. Once you get the live stream announcement over there, you will see there's a few link to be posted for you. So you can go to that few link to take the information that you need for revision. So there, like this week, I posted a few videos on YouTube, especially on YouTube videos, short videos. You wouldn't total up the video. I wouldn't let you go more than 30 minutes to watch all the video because more than 30 minutes is a okay. And I also will compile all the SPM trial question that are related into the announcement. So you guys can download it from my Google Drive and do the question before you come to this live stream. And I really hope this live stream can not only help my students, but also it will help a lot of students outside that do not have enough money to go for tuition, and also that really wanted to look for something that they like and affordable timing that they. I know tuition centers, a lot of them are doing it. I don't think so they will do it. Block. Pretty crazy. Okay. So the only way is at home. Okay. Now, whatever it is, I can talk as long as I could. Now, what I want you guys to do is remember, if you have any questions, put it in the live chat over there. All right. So without further ado, I will actually start my session. Turn my PowerPoint off first. Okay, I will start my session. So do you like the monkey over there? All right. Yeah, I draw the monkey on my phone myself. Okay, and yeah, cool. Let's do it, guys. So before we get to start the session, we have a few things first. I would like a vote first. All right. Please put it on the chat if you like BM or if you like it to be in English. If you like it to be in BM, put BM. If you like it to be English, put English. So I know how can I cater to you. All right, please put it in chat first. But before you, I will just go on and then I'll come back and look later. Okay. So with this topic is about linear motion. Linear motion is topic 2.1 in your textbook. All right. It's 2.1. What we need to do is we have a few things covered over here, which is linear motion. We have to talk about equations first. Okay, linear motion, whatever it is, the most important thing over here might be the equations. All right, so let's start with the equations. I hope you can see. Okay, good. All good. I'm starting right here. Okay, linear motion equation, there are a few. Okay, you have velocity equals to displacement divided by time, or speed is equals to distance divided by time. Okay, so this is the first equation. The second equation would be A, acceleration, is V minus U over T. All right, these two are the basic equations that you must know. Another equation you might want to know, average velocity is also equals to initial velocity plus final initial velocity, get the total, all right? V plus U or U plus V, doesn't matter, divide by 2. That is average velocity. Where this average velocity over here, what you can do is you can substitute it over here. Actually, the same thing. All right, the ones I highlight in red. Okay, now when we integrate all these equations together, you will get something that you have in your textbook, which is S is equals to average velocity V plus U divided by 2 times. This is the first one. Integrate it out, okay? When we put everything together. Kita letak semua sekali, akan dapat yang ni lah. Alright? Okay, so, and then once we go on and on, we have this one. We have these few equations. B square minus U square is equals to 2AS. This is the first one. Or the second one is S is equals to UT plus half AT square. So how do we want to remember all these formula? You see, always I always put VU. Yeah, I'll highlight it in yellow. You see, I always put V minus U. I always put VU, put VU. So I wouldn't get confused with the V and U, right? So, but this one, the last one over here, I don't really have any talk about. Okay, now these are just equations, right? Now let's go into the concept of. Okay, as we do the questions, we'll be able to discover a little bit more about the concepts. Okay, and let's jump into questions. Okay, so let's start with the first question first. Okay, slow catch the monkey SPM 2021. All right, this is how we're gonna do it. We're gonna look at the question over here. Right, let me see at the chat. Ooh, fantastic. We have 7 viewers today. Okay, now we are not going to do the first question first because the first question looks absolutely too easy. Wah, sir, biar betul first question looks absolutely too easy. Okay, now we are going to look at question number, this question. Okay, diagram 2 shows a boy standing on the platform. Okay, let me check my OBS. Oh, no, don't have my face there. Ah, there you go. That's me, okay? All right. Diagram 2 shows a boy standing on the platform of a train station watching a train. Train starts to move from rest. Acceleration 0.2. How do we want to do this kind of question? The first very important thing is you have to read the question and then you have to highlight the most important. Okay. From rest. That means it starts from rest. Okay. Acceleration, right? Time 24 seconds. So we have over here from rest, start from rest. So initial velocity U is equals to 0. I'm not going to go over a lot of basics. Just going to go questions. If you have any questions, ask me afterwards. This is acceleration. All right. This is your time. Okay. So these are all the elements. The first step is you label everything. It's just simply label, just blah only. Okay, don't go susah payah. Just blasa only. See the ring light in my eyes. Okay, so yeah, and then after you get this, the most important thing is you need to, the second step, first step is you label, the second step is you get the equation that is related, right? What are you trying to find over here? What is the length of the train? It asks you the length of the train, the length which is sasaran. Okay, it says the train is moving, bah. All right, so how do we want to go is we have a lot of equations. So many equations, we don't even know which use, right? If we refer back to just now, we get this equation as equals to UT plus half AT square. What you do is you substitute everything. Basically, boom. All right. But if you cannot remember this one, you cannot remember this one, you feel this one is too difficult to remember, okay, don't worry about that. you got the equation in front, basically. You have the equation in front, which goes like this. In the formula sheet, it is given you this one. V is equals to you can't read AT. Yeah. This is given in front in the formula sheet, but I don't like to use this equation because this equation doesn't make sense to me. It doesn't make sense to me, so I prefer to use the same type kind of equation. A acceleration is change in velocity, the rate of change of velocity. Rate is the time, change is E minus, right? Final minus E. That's how the thinking goes. Right? So what you can do is you can use this equation, okay? You find your V first, all right? Then you get to the next equation. You have your V, right? You have your V, and then you have your V. Now you want to find your S. You know V, you can have V plus U divided by 2 is your average velocity. Okay, and then your average velocity times your time is your displacement rate. So I go step 1, step 2, step 3. Longer step because you forgot the, okay, so not an issue also. So this is how we play with the formulas. Okay, you play with the formulas. Overall, you must be smart. So you replace the value, you dump it in, you get the answer, right? Don't forget a few things also. You must remember, don't forget to make sure everything is in. Right, so let's see. Let's look at another question over here. Okay, which of the following indicates zero acceleration? Zero acceleration, right? Now, okay, sorry, we shall not move in. Now, why today another topic is that I am integrating free fall, linear motion together. Linear motion is basically linear motion, horizontal. Free fall is basically the up and down, but both means the same thing. It's in a straight line, so both are linear motion. Just that in free fall, okay, linear motion, you have acceleration. In free fall, you have gravity. That's it. In linear motion, kita ada besaran. We have displacement. In free fall, we have height. Okay, so these are the two things that we need to take care over here. All right. So, and also, when we are here, it's important to talk about another element that is very important over here: acceleration. A lot of the times we associate acceleration with two things: acceleration, deceleration. All the time, if it's acceleration, it is a positive. If it's the deceleration, it is a negative A. But sometimes acceleration in the positive direction, positive. Acceleration in the negative direction is a negative. Right? So what's very important over here is we'll see whether we can get to that question. Okay? We have a question like that. You set your direction. Do not let the textbook set the direction. You set the direction. You set arah tu, jangan bagi siapa-siapa set arah. Okay? So, let's see. You have this one. We'll go into the next question. We'll go into a free fall question. Okay? Free fall question. Let's see. Which of the following indicates zero acceleration? That means that thing tak accelerate. So, durian falling down from a tree. It goes faster and faster, right? The durian. So the first one confirmed wrong already. Okay. The second one, netball thrown up the sky at the beginning of the game. So this one is concerned positive G. Netball throw up. As it goes up, it goes slower and slower and slower and slower, slower and slower, and it stop. Then it jatuh and come faster down. Okay. So this one is a negative G. Or this one is a positive acceleration. This is a negative, okay, deceleration. A force of 2 Newton acting on a toy car on a rough surface with frictional force of 2 Newton. This one advanced a bit, you guys should know. Here 2 Newton, here 2 Newton, I push it, although that thing is moving, but that thing moving with constant velocity, there is no acceleration. Okay, so the answer is this one lah, basically. Aircraft climbing up to a certain height, not enough information. Okay, so hmm. All right, let's get to the question. As we agreed with, diagram 4 shows a 1.2-meter height girl throwing a ball vertically upwards, velocity of 20 meter. Okay, that means this girl throw up, this one is 20 ms. This is start with U, right? Determine the total distance taken by the ball until it reaches the ground. Now, in this case, I always want to set my over here. I would set it correct. A lot of the time, your textbook will show you turun is always the positive direction, naik is always the negative direction. Or the other way around. I can't remember. So I set. Okay? I set now going up is positive direction. Coming down is no problem, no issue. So I have going up. Okay, I have going up as U, positive. Velocity, positive direction. Okay. Then I have the V. V on top here for free fall. Remember, guys, is always 0 meter per second because it stops up there. Also at a positive. However, my A here, now, due to the fact that it is, when you go up, you're fighting the gravity, you are decelerating. So I put my A as negative lah. Logic ma. Okay, 9.81. I think this is the value used up there. Okay. Check your formula sheet, guys. Before you start, check your formula sheet. The formula sheet is 9.8. All right. So what's gonna happen is that 9.81 or 10, doesn't matter. Get to it. Get to it. So we get to over here lah. All right. You have your formula v square minus u square equals to 2as. Why I like this equation is because it looks like this lah. V minus u over t is equals to a. A is over here, v is over here, u is over here. It locates about the same way. It's easy for you to memorize the equation. You don't mess it up, okay? You don't mess it up. You follow back whatever that I do just now. If you need me to reverse back just now, do tell me about it. Okay, do tell me about it. So we have this one, okay? So you just ganti everything masuk lah. You have you have negative 20 square, you have your 2, you have your negative 9.81. I think here they don't use 9.81, they use 10. If I'm not mistaken. I think they use 10. Okay. So they don't use 9.81. Okay, fine. I use 10 over here. Right? Let's use 10. Okay, don't use 9.81, use 10. So we have over here negative 400, negative 20s. S is equals to 20 meter. All right, so 20 meter, we have 1.2, you have 1.2. Go up 20 meter, go up 20 meter, come back up 20, come back down here 20 meter. Don't forget another 1.2 meter. Okay, so here 20 meter, here 20 meter, here 1.2 meter. So you have 41.2. Okay, now imagine if you set the direction. If you set the direction downwards is positive. Imagine what will happen is you have all these values go negative, and then your acceleration, positive or negative lah. Acceleration. If I go and put negative, not much of an issue. Also, actually, you will still get the same answer. But yeah, sometimes when you have too many negative values, you get too confused. Okay, all right. So we're good with this one. Okay. So the next one that I want to revise with you over here for today is actually our graphs. Okay, graphs. So graphs we have three type. Tiga jenis graph. Kita orang ada tiga jenis graph. Graph yang pertama S lawan T. Graph yang kedua B lawan T. Graph yang ketiga A lawan. Okay, so very easy. ST, kecerunan ST it goes to V. Alright, kecerunan ST ialah V. Kecerunan VT ialah A. Alright, so sir, apa maksud kecerunan? Sir, apa maksud kecerunan? So let's check this out. The gradient. So what happens if I have an object that is going straight line? Look at the gradient. Is there a change in gradient? What is gradient? Gradient is how much of slants it has. Do we have a change in gradient? No. Okay. The gradient, does it have a gradient? Yes, there is a certain value of gradient. Okay. So when we translate the graph over here, if no change, that means here, no change. You draw a straight line across. Okay. Now, if let's say I have like this, if that thing stays, is there a change in gradient? No. But is there a gradient? That line, gradient 0. So over here, I draw the line at 0. Okay, simple as that. Goes this way. So now, how we want to do is, if I have something that looks like this, okay, first one gradient is like this. Second one gradient is like this. Third one gradient is, wow, it goes up. The gradient is increasing. So when we come to V and T, we know the gradient is increasing. Know the gradient is increasing. We know the gradient is increasing. That means the value is going to increase over here. Okay, if the gradient is flat, same value, Vt, same value. If the gradient is increasing, Vt go up. Okay, simple as that. Now from here, I want to translate over there, next door. Gradient. Is there a value? Yes. Is it 0? Of course, no. But is it increasing? No, it's not increasing. You see here. How steep is it? Berapa cerun? It's the same throughout. No, it's the same throughout. The gradient is the same throughout. The gradient here translates into this value. The gradient here translates into the value here. Okay, that's how the concept of the graph goes. Now, okay, with all this information, it's very important lah, huh? Okay, now the one more thing is very important. Area under the graph of a VT is your distance covered. Let's get into question. Let's not talk too much. Let's get into question. So I would like to let you to look at this question over here. Okay, right. Diagram 2, Raja 2 menunjukkan graf sesaran masa, shows a displacement time graph, okay, for a car that is moving. Which pair of object motion from P to R is correct? You see, this is a displacement versus time graph. Displacement versus time graph, right? This E. So why don't highlight lah? Highlight lah. Highlight. Okay. All right. Okay. Let's go. Let's go. Next one. So let's see. Which pair of the motion from P to R is correct? Now you see. Use back the same analogy just now. All right. If it goes like this, okay, if it goes like this, goes up like this, goes up like this, okay, sasaran bertambah, displacement increase. But is the speed increasing? Speed, you have to look at gradient. It didn't increase. Gradient is the same. Same slope. Okay, same slope is means same gradient. So uniform velocity. Okay. Now this one, it goes down. Goes down. I know this one goes down means it goes constant. Okay. But the question is the slope you okay, cool. All right, we're back. We're back. I'm sorry. We I had a little bit of lag just now. Gila sudah just now. Okay, gila sudah. I also don't know why. Okay, just a while only, right? Okay. So basically, what I just repeat last one is that dia terbalik lah. Dia go from Q back to R. R is your zero. R is actually the same location as your P. 0 to 0. Okay. So it goes back to the original point. Velocity decrease. Look at the gradient. Cerun dia tukar ke tak tukar. Okay, that is graph for you. Short one, quick one, that is graph for you. Second one is you look at, I think you look at area under the graph. Okay, you have halaju masa. Okay, total distance is traveled is 600 cm. Determine the value of T. So they want you to determine the value of T. So what you have to do is you have to take 600 minus of this one, minus of this one, to find your T lor. Okay. So how to do? Find the T. This one is in the middle lah. You think so easy as a very right? You have your 20 here. Okay. So you have 10 and 20 divide by 2. The first one is 10, 20 divide by 2. 10, 20 divide by 2. Faster, 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 faster. It's 100. Okay. 10, 20, 200, 200 divide by 2, 100. Okay. The one at the back here. But we know over here is a trapezium. So now you have 600, you remain with 100. Okay? Area under the graph is a trapezium. Trapezium formula, half A plus B is equals to times C is equals to your area. All right. So you have your A, you have your B. Do you have your A? A is 10 to 40. B is 10 to. All right. Basically 10 to T, we don't know. All right. 10 to T, we don't care lah. We just put T lah. Sorry, we just put X. Don't put T. Put T. We just put X. Let it be X. 10 to 40 is basically 30. So you have half 30 plus X is times your height. Your height is 20 is equals to 500. Ta-da. Go get your X, guys. Right? Go get your X. That's all. And then once you get your X already, hey, don't forget, T is 10 plus X. Okay. 10 plus X, not X. T is not X because X is just this length. Don't forget, you start at 10. This point start at 10, this point end at 10. Okay. In the middle is X. So get your X. All right, so I'll jump. Okay, I'm not going to calculate. To be honest, I didn't calculate also. Leave you guys to calculate lah. Okay, so yep, let's go into ticker timer. Ticker timer is the last thing that I want to talk about over here. All right, ticker timer is the last thing that I want to talk about. Basically, what is ticker timer? Ticker timer is actually just some simple strip. Okay, if we run the experiment, the ticker timer will start tick 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 tick. The distance getting bigger and bigger and bigger and bigger and bigger. Okay, so the typical ticker timer as stated in the question will usually be 50 hertz. 50 hertz means it hit the paper 50 times. Okay, form force, if you're here, I'm sorry. We need to go back to school to do the experiment. Okay, so we have 50. Now we have 50 times in 1 second. right? We have 50 times in 1 second. Hit 50 times in 1 second. So one round from here to here, how long? If it's 50 times. So 50 times in 1 second. In 1 second. So one dot to the next dot is how long? 1 divided by 50. 0.02 second. So one dot to the next dot is 0.02 second. That is ticker timer. All right, that is ticker timer. And how do we know that how to calculate ticker timer? Go into question. Go to the question. So we have the first question talks about it. We have the very first question talks about a ticker timer. What is the total displacement? Total displacement tak payah lah, just tambah everything together. They give you the length already, you just tambah the displacement, settle. I want to challenge you a little bit. What? A, B. Before I do anything on that, okay? Right? I would actually do this. Wait, how to blanco white? Title. Never mind. Okay, we are not going to talk about the last one if we want to do this question. Okay, last part, wait. Oh, this part. Oh, wait. Okay, I jumped in the right. Displacement very easy to calculate. I want you to calculate acceleration. Okay, as you know, the formula acceleration is v minus u over. Okay, so how do we want to minus u over t? V and u, how to calculate first, sir? Abe lah, V and u also don't know how to calculate. You want me to calculate t some more? And then you're going to calculate A. Habis, tak boleh, tak boleh. Take the first line. Okay, take these two. Now, what you have over here is you have the displacement divided by time is your average velocity. So how many dots you have here? 1 space, 2, 3, 4, 5 space. 0.02 times 5 is 0.1 second. Okay, cool. So the first one over here is 2 divided by 2.0 divided by 0.1. We have 20 ms negative 1. Okay, now the last one pula, 8 divided by 0.1. So you have 80 ms negative 1. Okay, you have the first one, you have the last one. Right? Now, we are going to calculate the acceleration. Now, how to calculate the acceleration? We have A, you have here, you have V already. Sorry, this is your U, this is your V. You have your V minus U over T. Now, your T, don't be deceived. Please don't be deceived, okay? You don't take into consideration the first line. Because the first one, you only hit 80 here. Sorry, you only hit 20 at the when you have this strip. But before that, did it start from 0? You actually have to start from 0 if you want to calculate. You have to start from the bottom. But we don't know what is from the bottom. We don't know what is the strip before that. The last strip may be like when the fella do experiment, the fella koyak and then the fella throw it away. Or because he cannot see the dots. Or sometimes when you do the experiment, you can see the dots. When it just started, the dots just go like this. So you don't know. So the first strip, we throw it away when we calculate the t. All right? Don't throw away everything. So you have 80 minus 20 divide by, yeah, I'm calculating velocity, I'm calculating acceleration now. Add on to the question. Add on to the question. How many strips? 1, 2, 3 strips only. 3 strips only. 3 strips, each strip 0.1. That is our accelerator. Okay? So I'm not gonna move into it. You need to calculate it yourself. You need to settle it yourself, all these things. I'm just giving you the important basics to run all the questions that is needed. Okay, now I want to know so far everyone is okay or not okay. Everyone is okay. Give me some response, man. Okay. Now that just want to know. Yep, put something in the chat box. Okay, I'm going into subjective questions. Yeah, I'm going into subjective questions. Subjective questions. Subjective. Yes. Type in your questions. Okay, don't type on WhatsApp. No, but I will. I actually airplane mode my. Type in your question. I'll get back to there when I have the little bit of time. Meanwhile, I will talk in. How I get the 0.02? It's a standard specific. Okay, how I get the 0.02 time? Okay, never mind. Well, let me start with this. Why is it 0.02? Is because if you go and flip your electric appliances at home, you will get 0.0, you will get 50 hertz. You will see something like 50. Okay, that means the current is jumping 50 times in 1 second. Okay, when we take this and we connect into the ticker timer. The ticker timer is a device that has a plate. The plate is connected to a spring, and the spring, and it's connected to a magnet now. Okay, when the magnet gets another electric, okay, when the magnet accepts the electric, the magnet will turn on, off, on, off, on, off, on, off, on, off, on. Okay, the magnet will turn on, off, on, off. So if my electricity jumps 50 times in a second, that means the magnet on, off 50 times in a second also. That's how it happens. Okay, the magnet goes 50 times a second. That's why that plate will swing 50 times a second. And once it hits the paper, it will make a mark. Okay, and the paper is running. That means once it hit the paper, one dot, the next paper, another 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 dot. Okay, so that's how it happens. That's why 50 hertz means 50 times it hits in a second. So from one to the next one, I have to use 50. So from one dot to the next dot, I have to use 1 second divided by 50 times. That's how I get the 0.02. It is actually the natural natural frequency. It is actually the origin, the frequency that is provided in. Okay, I hope I answered your. Yeah, that's how it goes. You can go check out your phone. Cool ring light here. Okay, cool. Let me take a drink first. Okay, now let's get excited. Let's get into subjective questions. All right. Diagram. Let's do a little bit lah. This one. Diagram 5 shows a stroboscopic photograph of a falling ball towards the ground. Falling ball falls to the ground. So is it accelerating or is it accelerating? You don't know. But as we see, the distance increase from one ball to the next ball. Okay, distance increase from time to time. That means the thing is accelerating. Decreasing velocity? No. Constant velocity? Maybe. Increasing acceleration? Maybe. But I would say constant acceleration because in your numbers you have acceleration. Okay. So, well, it's gravity. It's constant acceleration. Okay. constant acceleration, gravity, set at the value 9.81 or 10. Okay, there's a little bit of error over here. Diagram 1 shows a displacement time graph of a toy car. Okay, tandakan jawapan yang betul dalam kotak yang disediakan. Displacement is a scalar or vector quantity. It's a vector quantity. That's that. Right? Hey, now let's go. What is the meaning of displacement? The meaning of displacement. Meaning. They ask you meaning. Meaning of displacement. You like, sir, displacement is displacement. Now, how to answer the meaning? What are you calculating in displacement? You are calculating distance. You're calculating length. All right. But how you calculate the length? Go back to your textbook. Check your textbook. I'm not going to answer this question, but I will give you the answer. All right. It is the shortest distance between 2 points, or shortest length between 2 points. Keywords, I'm giving you the keyword. 2 points. Okay, the last one, at a specific direction. Okay. If it has no direction, it sometimes go left, sometimes go right, sometimes go up, sometimes go down. When it move, okay, like a marble fella, that is distance. Displacement is very specific. Got direction. That is your displacement. Okay. State the physical quantity represented by the gradients of the graph. You have to know it. If it's displacement time, it is. Gradient is your velocity. State the time interval when it is at stationary. Stationary means it's not moving. Over here. It doesn't mean 0 is stationary. Here is the displacement did not change. That means the fella go out of the house, he stands outside that house, he doesn't move. Is he stationary? Yes. But the house is 0. Go out 5 meters away from the house. Out of the house. And he stand there. Is he stationary? Yes. So this is 8 seconds. Okay. So you know it is 8 seconds. Now sketch the graph of velocity time for the toy car. So if we want to sketch the time, velocity time graph, let's do this as a challenge. Okay. Effort, velocity time graph, VT. Okay. VT graph. We have velocity time graph. Don't forget, when you sketch your graph, you must have your label. Meter per second. This is your. Okay. So when we want to sketch the graph, how does it go? What is the gradient? You ask the question, what is the gradient here? The first part from 0 to 8 second gradient is 0. Gradient is 0, then you put 0 lah. So, not moving mah. Sorry. Yo, die lah this time. Go backwards on YouTube some more. Okay. Alright, the next one. Now the fella Gostan. The fella Gostan. Gradient. Gradient got 2 types. Oh yeah, this one just now forgot. Gradient positive, gradient negative. Okay, positive gradient, negative gradient. If this one is negative gradient over here, is there a value to the gradient? Yes. Does the gradient change? No, it didn't change. Same slope, same slope, same slope. That means I'm going to translate it into a value. It is a negative gradient. That means in the VT graph, it is a negative. If in the ST graph, listen, if in the ST graph is a negative gradient, in the VT graph is a negative value. In the ST graph, the gradient doesn't change, but has a value. In the ST graph, the value doesn't change, has a value. Okay? Negative value. Okay? But it flat? Yes. Value does not. The gradient does not change here, so the value does not change here. Okay, we're good. it looks like this is a good challenge question for you guys to understand a little. Gradient translate in. Okay, we'll try to do more exercise as we go along the chapter. There's so many topics in the sure you can. All right. Yes, sir, this kind of question again. I leave this one to you. I'm not. Okay. Calculate the distance. Calculate the distance. Very easy. Only you just calculate whatever the area under the curve already. All right. So let's go to this one. This question, chapter 5. You are on chapter 2. How can you do this question? Nah lah. What kind of nonsense is this? Diagram 12.1 shows a sonar on the ship. Which boat uses a sonar to determine the depth of a seabed? Now, the next question. I took out the question a little bit, okay? If the time taken for the return of waves, that means the wave go out and the wave come back, is 1/15 second. Calculate the depth of the shoal of fish. Okay, I draw a fish there. Below the boat, if the speed of sound is 1,500 meters. So, it goes same way. This is your T. Okay, this is your T. This is your T. Right? Good news here is 1,000 starts 1,500, it ends 1,500. So your U and V. Then you need to use the same one formula only. S is equals to V, right? But that. Velocity is displacement divided by, or speed is distance divided by time. Okay, let's go, guys. Piece of cake, come on. 1,500 D 1/15. Okay, bring this one up. Then your D should be 100. Hey, 100 meter, wait. Your distance is 100 meter, huh? Don't forget, huh? That thing goes down, come back 100. So the depth is 100 divided by 50 meters. A very famous question in SPM. I think I saw the inside. But this is trial question. They always come out one. Trial, this question very famous. I don't know why. All the trial people love this question. Came out in SPM before. Last time. Okay. So let's see, huh? You good? Pretty easy. So the distance is 50 meter. That's the depth. You easy. Don't forget, the 100 is go down and come up. All right, settle. We're good. We're good. Let's go. Of course, you can have a little bit of different formula. You can combine the formula, which is later you will in your textbook. Okay, textbook is B is equals to, I can't remember. I can't remember how they do it. I think is S your word, where this D is your depth. Okay. Well, if you want to use formula, it's this way. If you don't want to use formula, you just remember V is equal time, which you learn in your science, and you know the distance is like you come down and then come up, so you need to divide by 2 lah. Okay, good. There we go. Okay, diagram 4 shows a boy throwing a ball upwards at 10 meter per second. Okay, at 10 meter per second, ball decelerate to a maximum height before accelerating downwards. Okay, so he throw up 10 meter per second. Go up 0 lah when you reach the top. State the change of energy which happened when ball is moving upwards. From bottom, you throw. What kind of energy? You throw. It's speed. It's kinetic energy. Write short form. Don't write short form in a it's angular. Okay. And then when you reach the top, it gets gravitational potential energy. Okay. So that's it. State the type of motion of the ball when it falls. Huh? Type of motion. Go back to the 4 types of motion. 4 types of motion. Stationary pegun. Uniform velocity. Hal laju seragam. Acceleration pecutan. Deceleration nyah pecutan. Come down. Not accelerate lah. Acceleration. Now, if you don't know it is increasing, decreasing acceleration, just write acceleration first. But no, not increasing, decreasing, but it is constant. Okay, doesn't matter. Just write acceleration. Name one force that is acting on the ball during this motion. The force. Okay, you can write gravitation force. You can write weight. Right? Use an equation v minus v equals to u. Calculate the maximum height. Your height. All right. Have your height over here. You have your v. V is 0. V now this is v. V equals to 0. U equals. Okay. So we have v is 0. Okay. U is your 10 square plus 2. All right. Going up. Deceleration. Because I said the going up to be positive. My wish, man. Okay, my rules. Your displacement, your height. Okay, so now you have it 100 plus negative 20 s. Move it about. You have 20s is equals to 100. S is equals to 5 meter. Okay. Sketch a velocity against time t graph. Describe the motion of the ball. To describe the motion. Don't forget, when you write your velocity time graph, remember to start it with dt. Don't forget. I'm not sure in SPM if they do like this, you need to put unit or not, but it's to be safe. Let's put it. Okay, let's put it. Now, you start at a high velocity, right? You throw 10. The velocity decelerate straight line, constant. Okay, the speed going down constant. 10, 0. As it comes down, it accelerates back to 10. Okay, now of course it can go a little drop on the floor lah. Okay, drop on the floor. But all these lines are straight lines. Yup, basically that's all the discussion for today. And it looks a little bit very simple. I hope this simplify a lot of SPM question for you guys. SPM style questions. These are trial questions from each state. I would really want to do a shout out and thank you for all the SPM trial paper designers, okay, from all the states in Malaysia. Thank you for sharing all these papers out, those that compiled this paper. I really appreciate that. Because all these paper, I'm going to use them, make Malaysians education system better. Free tuition. Okay, so see you guys next week. Next week, same time, same style. I'll post up the content, I'll post up the information. You go and take a read, you go and try out the question a little bit, or read out the question a little bit. If you do not have enough time, come back. Boom. Slow catch the monkey. The monkey is fast, and you are slower than the monkey. Have to go catch it slowly. Use your brain. That's your SPM. See you guys around, and love you all.